Star systems can be incredibly complicated things. One system, for example, discovered in 2015, contains 5 stars all orbiting each other, 2 of them so closely that they share outer atmospheres. This interplay of major gravitational sources and multiple star systems complicates the possibility of stable orbits of any planets within these systems. Stability is a major factor in whether life can arise on a world. You won't get very far if your planet periodically freezes over and then bakes as it negotiates its way around double suns. Since multiple star systems make up a significant portion of the star systems in the Milky Way, this problem likely precludes complex life in a lot of systems. But not all. Multiple star systems are situational by their very nature. A good case would be the closest known exoplanet to Earth, Proxima b. See my videos on that planet on this channel. The star it orbits, Proxima Centauri, has recently been shown to be part of the Alpha Centauri system and gravitationally bound to the 2 larger stars in that system. Yet, Proxima b does have stability and is considered a candidate for possibly harboring life. Proxima b's chances for harboring life aren't that great. Proxima Centauri itself is a red dwarf star, which in recent months have been questioned as to their suitability for harboring truly habitable zones due to the close-in proximity to the star. There are many systems where better stars are separated enough to allow for stable orbits around those stars. This may make them prime candidates for civilizations to develop around and colonize. After all, if you want to generate energy for your civilization, 2 stars are better than 1. It's always natural to colonize close-by planets first. We look to Mars, for example, because it's right next door, as opposed to heading off to Proxima b on a decades-long trek to found our first interstellar colony. One of the things that will drive the colonization of the solar system will be resources. The moment someone demonstrates that money can be made mining the solar system, it will very likely spark off exploration and colonization at a breakneck speed. Those resources in our solar system are not yet completely clear, but in a double star system, the energy resources of that second, more distant sun would be obvious to a civilization. Civilizations building colonies around a second star in their system would need communications between those colonies, much in the same way that we do that with our interplanetary probes. Radio and laser communications have shown to be perfectly good for this. We use it, we know it works. Technological alien civilizations would know that too, and given that communications times between 2 binary stars would be comparable to communications times in a solar system such as ours, this may make for a very unique method for SETI to detect such civilizations easier than it might be for single-star system civilizations. In his book, Sharing the Universe: Perspectives on Extraterrestrial Life, Seth Shostak points out that occasionally widely separated double-star systems will be oriented just so as to eclipse each other from our perspective. Observing those star systems during eclipses gives an advantage to detecting signals. You're lined right up, looking down the barrel of the gun, so to speak. And the chances for double star systems to host Earth-like planets has been rising lately. Recent modeling by Max Popp and Siegfried Egel, linked to the paper below, bolsters the possibility of habitable zones and double star systems. Civilizations living in such star systems would have Tatooine-like worlds with double suns in the skies. One wonders how that might affect life and evolution on such planets.